I would start by asking both of our panelists how they first wanted to get into their field, what inspired them from day one. Maybe we can take it from there.
All right, I guess my interest in the field, I always just loved and enjoying learning how to take things apart, seeing how they work, putting them back together again. And so that's why I chose mechanical engineering. And then I got into more of the research side of things and progressed then into a faculty position after getting the advanced degrees.
Excellent. Siddharth?
Yeah, my choice exactly. My major thing is when I joined the engineering, mechanical engineering was, my uncle was mechanical engineering, my another uncle was mechanical engineering. So that creates motivated me. And the second thing is my interest in design and manufacturing that brought me into the mechanical and then later on in the CAD/CAM. So that's what it is.
Excellent. Yeah, it's usually a family business sometimes. So we have a question here. Maybe start with Jason. So, what are the pros and cons of starting with, a bachelor's versus a master's versus a PhD? So, from your academic experience, what are the different tracks that can lead you in those directions?
Right, and so you'll start out with your bachelor's degree, and that's perfectly suited for going into industry and progressing from there if your role is within industry. As you continue on, a master's degree is going to be beneficial to both industry and research areas. And typically then if you want to go on into academia, that's where you want to get your PhD or into advanced research areas as well.
Excellent. And Siddharth, in your experience, where did those different tracks take you?
I agree with the Jason. Like first, a bachelor degree is related with the foundations, fundamentals of the engineering, which help definitely in the industries. If you would like to have a research interest and would you like to go with the academias, definitely masters will help. But at the same time, becoming a little bit on the micro sides, like with the master's degree, that will also helpful in the industries. If you do have more interest in the research, definitely PhD is going to be helpful. And in academia, as you know, that PhD is one of the first things which you need to have. So this is what the 3 steps I would like to have. Bachelor's is more on the foundation sides, giving overall idea about the engineering.
Excellent, thank you. We now have a question in the chat asking, what are some of the biggest challenges you've faced in the academic field? And that could be a range of when you started versus where you are now. Of course, with the COVID context, there's a lot of pivoting going on, which is probably reimagining everything, but just general challenges you faced in academia.
I guess from my standpoint, the PhD is a different beast altogether. As you go through your bachelor's and master's degree, it is just a matter of going through and doing the process. But with the PhD, you're really looking at pushing that envelope of technology, and that is a difficult process.
Certainly. Siddharth, anything to add?
One of the like what I from my perceptions, keeping pace with the industry, keeping yourself aligned with the industry. At the same time, you are teaching at the undergraduate level, you are teaching at the master's levels, you are guiding PhD students. So keeping all these 3 aligned, and at the same time keeping yourself aligned with the industry developments, latest technologies. So you need to develop in academia as a teacher. That is how you can teach, how can you make sure, and at the same time keeping yourself on the research side. So you have to match both the things. That is what, according to me, one of the great challenge and joy of learning.
Awesome. Thank you for that. I think that's really helpful. We now have a question here from someone asking about research specifically, and what role does doing research in your academic career, how does that help your career after university? And what does that do for either going into masters or into industry? In your experience, what is the role of research there?
I think in general, that's really the kind of the expansion of our field as we move forward. And so the research that you do in academia, you're really looking at applying that, seeing if that can be used in industry. ASME is really helpful as they provide conferences where you can share that information. And so it serves that purpose of really continually developing our field.
So in continuation with this, Yeah, like research as that is one of the field, one of the area where you will be you are expert, and that will be definitely helpful to your institute, organizations, universities. And at the same time, like research projects at master's level and research projects at PhD level, your research that will be in collaboration with the industries, or any of the research project which you are going to take it, that will be going to use after all in the industry areas. At the same time, as Jason has rightly mentioned, some of the research field interest later on at the later stage of your career will help you to develop your entrepreneurial skills, or starting your consultancies with the academia. So that is one of the best part. Being as academicians, quite active in your research projects, helping you to connect with the industry, and that will help you to have some consultancy projects on board.
I think a nice related question as a follow-up we have here is what is the different benefits of working before going into a master's program versus going directly from undergraduate to master's? Can you both talk about what you've seen in your experience, either personally or with students going down that path?
Right. From my experience, I did work in industry as an undergrad through co-op experiences. And what I saw was that I really wanted to be more involved with research. And so I kind of did that process where I just went straight through for all three of my degrees. I think the benefits of doing that is you're kind of in that academic mindset. The flip side on going into industry first before getting your master's, oftentimes industry will pay for that, whether it be a master's in science and mechanical engineering, or if it's a master's in business. So you can kind of decide which path you want to go once you're in industry.
Excellent. Siddharth, anything to add there?
Oh, I love this question. It's a wonderful question, and this is what actually helped me with the professional experience. Like when I was like from my perceptions, doing the undergraduate level and directly jumping into the master. Sometimes with the experience, it helped you to have your focused area, what you like to do and what you did not like to do. Second point, which Jason has already mentioned, you will be getting the leave for the study from your company for your organizations, and that will be added advantage. Specifically, if I'm talking from my perspective, uh, I was sure about what type of topic and specialization I would like to jump in for my master's program, and my project and my research area and everything was almost confirmed with my experience. So that is one of the best thing with the experience when you have experience working with any of the organization.
Excellent. That's some really good direct advice. Thank you for that. I think a really cool question that just came in is about how you can go into academia if you really like teaching, but you don't think that you have the mind for research. So what are the different options for someone who's really passionate about instructing and leading, but maybe doesn't get in through a research track?
Right. There's usually two separate tracks. The tenure track is the professorial path, where you go assistant, associate, and full professor. If you're just interested in teaching, there are universities that specialize in that undergraduate education. And then in addition to that, there's the path where you have, say, a lecturer or senior lecturer, where you're not involved with the research side of things.
Siddharth, anything to add on that one?
Yeah, that's like, see, recently like engineering education, ASEE, and the one of the thing which those so much interested in the education side, that is on the teaching sides. And Jason has rightly mentioned that totally depends on the different areas and as a country wise. Like some of the countries having the lecturer, senior lecturers, and that type of post, and some of the countries it like having this common post. But if you would like to have more research area, you have to work in the research laboratories with the associate professor or professor type of designations. And at the same time, you would have a little bit of workload or work assignment related with the teaching. But if you are much more interested in teaching, you can focus yourself with the full-time or full job in the teaching areas only.
Yep. And on top of that, too, you can even get your PhD in engineering education and focus on the science of learning.
Right. And I think with that, it's a good segue to kind of take us through a day in the life of your day to day. And I'm sure it's changed dramatically over the years, but so our attendees can get kind of a feel for these different areas that you're involved with. Take us through your typical Tuesday.
Right. And so I think the main thing, faculty are involved with three different areas, teaching, service, and research. And so on a typical day, on a Tuesday, I'll teach a class from 9:30 to 10:45, a graduate course on reliability engineering. I have a number of senior design projects, the teams that I advise. So I'll have the team meetings for the senior design projects. And then some of those are research related as well. So visit with some graduate students on their graduate studies. And so that's the typical day. And then being involved with ASME activities, First Lego League, all sorts of fun stuff.
That's great. Siddharth, what's your Tuesday look like?
For like looking towards my job and my responsibilities, Tuesday is much more related with the meetings, schedules meeting with my departmental faculty members. But yeah, evening is a little bit fine. That is the later part, and after the 3 p.m. having interactions with the students team, those who are doing their masters, a little bit of interactions with them, and that is what the best part. And generally Tuesday is considered as a with the regular monthly meetings, having one of the EFA steering committees with the ASME. So that is what the schedule calls once in a month.
Well, we like to hear that ASME is involved in your daily schedule, so that's good branding for us. But I have a good question here, very specific about if, say, you're a sophomore undergraduate and you're wanting to know where you can go. Is it good to have a specific goal for what to do after school, or does that something that you flesh out along the way? So I guess in both of your experiences, personally or with students, how do you see having that goal versus it develops naturally?
I think more often, I think it just develops naturally. There are a handful of students that come in that are very focused. They know exactly what they want to do with their careers, but I think that's less likely. I think more students just kind of transition, and it's just a natural progression on their career path.
Yes, I totally agree with that, and that is purely the natural process. Like slowly, steadily, with your study, with your likings, dislikings, your peers, you will develop the choice. You develop your taste. You like to know that in which field you like to develop yourself, and that is what more just like a natural process. Involvement with your day-to-day routine activities with the like exploring engineering, doing some projects, doing some works, and then it will be automatically will be getting your goal, getting your path.
Excellent. And I think we have a question here, which is a little more globally minded. So obviously you both have different perspectives there. In terms of finding a job, can you make some comparisons between the different markets, US, Canada, India, Europe? What are your thoughts there for our international audience members?
Siddharth, did you want to take that one?
Sure, I was about to ask that. Uh, like frankly telling you, I am having a good experience, having a little bit research experience in USA and having a research experience in India. US, Canada, specifically more intense research, if frankly telling you, and at the same time, the development of the engineering education field is very early in the stage. So if you would like to have, like from the US perspective, it is, very focused research. It is required advancement in the technologies. If I talk specifically in the Indian perspective where I'm right now living, is okay. So yeah, we are in the process of developing this research contest. No doubt, a few of the Indian institutes are doing great research in engineering field, but at the same time, it's a slowly steady. It is in the process. So I must say that is in the developing stage. Uh, Research in USA is very focused and intense one, and we as from the Indian perspective, it is slowly steadily taking the shapes. And few of the institutes are really doing good. That is IITs. They are really excellent at par with the uh, international universities. But yeah, uh, like in comparison with the other Europe, Canada, that we need to develop on that part. So a lot of opportunities in from the Indian perspective, having the research background and taking the career and as academia is in the research part.
And I'd just like to add that the mechanical engineering field is a really strong field to go into. Placement rates are typically around 95% for undergraduate students going into industry after graduation.
That's a really good segue because we have several questions here about the mechanical engineering field specifically. You know, what are the different tracks that people should take within? Is it better to stick with something, you know, more singularly minded, or is it better to play around as you're in your undergraduate career? Does that make you more attractive for a master's program, or versus what is industry looking for? You know, we are headed into an interdisciplinary world, but what are employers or admissions offices looking to see?
Right. And the good thing about our ABET accredited mechanical engineering programs is they provide you that the core areas of mechanical engineering being the mechanics area, the controls and thermal sciences. And so you get exposed to all three of those areas as an undergrad. And I do recommend to my advisees that they tend to specialize then in one of those three areas with their senior electives, and then kind of focus on that specialty as they go off into their careers.
I would like to focus more on interdisciplinary approach, which Jason has rightly mentioned, senior level projects in that way. If you would like to, if you have more choice, having interdisciplinary subjects, like looking from our perspective, having more freedom to choose, having the latest technology subjects as per your choice, then it will be as a major and minor subjects. Then it will be really good. And most important part, according to me, is your selection of your projects. That is also one of the key area. So having a little bit attention on the project sides, and I would like to advise all the youth, or say would like to prefer more to be on the latest technologies and advancement type of projects, which you must do already with that.
Yeah, and I guess speaking of projects, you know, a lot of skills development happens therein. So what are the key skills that our attendees should be focused on for the next few years as they try and develop their careers?
I think the biggest thing is really their communication skills. Everybody's going to have that strong technical background, but you really need to work well with other individuals from an engineering perspective and those that are not engineers. And so that's going to be beneficial throughout your career, just how you interact with others and in teams.
Would you say that there's much of a difference between the communications if you're going through the academic track versus if you're going through the industry track, or do those skills maintain in both fields?
Yeah, I think they just kind of transcend all fields that you go into.
Siddharth, anything to add on communication and skills development?
Yeah, exactly. Communication skills, Jason has rightly mentioned that, and I'm totally 100% agree with that. And at the same time, as you know, that with this pandemic, we really become the global, everything is on virtual. So communication skills with the different cultural perspective. So that means it is a little bit with the collaboration also. You being as a team member, you may have to work with the people from India, Asia, Europe, America, and everything. And as you know that with the communication skills, there are different types of cultural background, use of the language, use of the presentations, how to communicate effectively. So that is one of the most important skill, which according to me are going to take care.
So we are at about a minute left. I think with that minute, the difference between communication maybe and coding is now coming up, right? So what should mechanical engineering students have to know about this increasingly digital world, as was just mentioned, with coding and programming, those languages, a little different than the languages we're talking about right now?
Right. I've used coding a lot throughout my career, both within industry in terms of controlling actual measurement systems, as well as my PhD with doing finite element analysis, writing coding to generate models, that type of thing. So it is a very good idea to have a strong background in some type of language.
Siddharth, 20 seconds as we wrap up this portion.
Sure. Coding will work as a catalyst in your career. So being as a mechanical engineer, if you know code, it will become the catalyst. It will make your career straightforward in the vertical growth. That's it with the short and sweet answer for the coding.